Our next and final presentation from the day, for the day is by Neil Trevett. Those of you who've been with the Alliance for a while know that Neil is the head of Khronos, the industry standards group that has developed OpenCL, OpenVX, a number of other standards relevant for embedded vision. Neil's also a VP with NVIDIA and represents NVIDIA in the Alliance as well. Periodically, I'd like to have Neil in to update us on what Khronos is up to, new standards, standards under development, standards under consideration related to embedded vision, and Neil is kind enough to join us today to do that. Thank you very much.
Hey, thank you, Jeff. It's a pleasure to come and give you guys an update. Going to try and keep this high standard of the speakers up today. Hope I don't let the side down. But I'm happy to be here because we have a lot of standards that are relevant to embedded vision, and it's quite confusing. Even inside Khronos, there are multiple ways of doing vision processing. So often asked, which of your many APIs should we use? So hopefully, as well as giving you an update on the individual APIs, you can help provide some clarity as to when and where different applications might choose to use them. And for those of you who haven't come across Khronos before, we are an open standards organization. We are committed to creating royalty-free standards for connecting software developers to silicon acceleration. And the areas of silicon acceleration that have most industry interest right now are 3D graphics, which is where we started with OpenGL, general purpose parallel computation, and vision processing. Those are kind of the three hot areas. And we define kind of low-level APIs. It really is the driver-level interface into the acceleration for that type of functionality. So they're used across a number of different platforms. They're shipping in the embedded mobile desktop market. So a lot of people, a lot of their devices do use these APIs. So which are the APIs we're going to talk about today that are relevant to vision processing? Well, we have one, OpenVX, which is specifically for vision processing, but in particular trying to bring the power needed for always-on, real-time mobile and embedded vision processing down. But we also have more general purpose parallel computation frameworks, OpenCL, and a closely related standard called SPEAR, which might be new to many of you, which I'll give you a little bit of information on. And you can use those low-level parallel computation APIs to implement OpenVX. So we kind of have a layering thing going on. And last but not least, because a lot of systems today actually do use GPUs for vision acceleration, it is relevant to briefly talk about the GPU graphics and GPU compute APIs, the traditional generation OpenGL and OpenGLES, and the new generation GPU API, which is called Vulkan, which is just about to ship. So I'll give you some insight into that too. In fact, let's start there, and then we'll work backwards towards OpenVX.